Welcome to Healthcare Matters, bringing you the latest insights and innovations shaping the future of healthcare. This episode is powered by Medlab Middle East in partnership with PureLab. I'm your host, Peter Birch, and today we're exploring how laboratory medicine is evolving through automation, AI, and sustainability, and what this means for the future of diagnostics and personalised medicine. Joining me today is Arindam Haldar, CEO of PureLab, and in this episode, we discuss how AI and machine learning are enhancing diagnostic accuracy and efficiency, the shift towards personalised medicine, the importance of sustainability in lab operations, and what the future holds for emerging diseases and rapid testing. Arindam, welcome to the show.
Thank you. Thank you, Meet, for having me here. Greetings, everyone. Salam alaikum.
It's great to have you here to be able to dive in and understand a little bit more about, I guess, this evolving world of laboratory medicine. And there's a lot we can cover, but I feel like firstly, it'd be great to get you to set the scene and a bit of context about you and particularly PureLab and the role that it plays.
Sure. Thank you. Happy to do that. I am very fortunate to head PureLab, which is the largest integrated lab network in UAE, managing close to 150 labs across the 7 Emirates. And we are a proud group company of Pure Health, the largest integrated healthcare organization in this part of the globe. We deal in lab services, laboratory medicine, pathology, whatever you call it. Put very simply, this is that part of healthcare which comes in whenever you're sick or not sick. You go to a doctor and they write a bunch of tests. And much of those tests links to testing via some fluids or DNA of yours, whether it's blood, urine, it can be DNA. So whatever the test that happens is done. One part of it is radiology or imaging, which is your CT, MRI, and the rest of it is pathology or laboratory medicine. So in conventional term, pathology sort of influence 70% of the doctor's decision making in terms of what kind of medication or what kind of treatment as a patient you will have. So that's the role that we play as a backend and as a strong support to the physicians of the world.
I wasn't aware that it was so high. 70% of the clinicians' decisions are, I guess, informed by pathology. But that makes a lot of sense. You know, there's the consultation and the initial clinical diagnosis that a doctor may provide. But you know, you've got to have the evidence, and that's what healthcare is about. So I see how pathology and lab testing is mission critical. It's been around for a long time, as far as I'm concerned. But obviously, you would know that it's an evolving era. I'd love to learn a little bit more about how you've seen that the world of laboratory medicine evolve over the last couple of years.
Sure. So yeah, like every other industry, lab industry have evolved and constantly evolving. The only difference is the pace at which healthcare in general was evolving, and lab medicine is no different, was at a particular pace. And I think in the last few years, only thing that has happened is the pace of change has not only quadrupled, I guess it is growing at a hugely exponential rate. And a lot of developments are happening in all parts at a very fundamental level. Pathology and laboratory medicine saw automation and saw machine and doing a lot of the work from very early days. Many decades back, you had the analyzers, which does the chemical analysis, which does the mapping of your DNA, does chromosome mapping. So machines always did it. I think where we are evolving and evolving at an extremely high rate is how those machines are talking to each other, and more lately with AI and Gen AI coming in, how the machine is learning and becoming better, and how it's assisting us to go forward. And honestly, that is sort of transforming lab industry like nothing else.
Yeah, I'd love to double click on that a little bit more and hear where you think, I guess, this world of artificial intelligence and the impact that automation and things will have in the lab space. Do you think that it's like, what's the biggest need? Is it to improve the accuracy of a diagnosis in the lab circles, or is it about getting through more tests? Is that the higher priority, like the efficiency
Mhm,
side of
mhm,
things? Where do you
mhm,
think
mhm.
AI is going to have the biggest impact in the laboratory medicine?
Sure. I think where it will, and when I say it will transform, is it will change the landscape to a large extent where we have a self-evolving system. It goes both ways. When you say machine learning or artificial intelligence, AI is obviously constantly learning. What AI does, it assists our pathologists, the doctors who sit in the lab to take those critical decisions. So you can think of it like an airplane where you have a pilot, you have a autopilot, and you have all the AI which sort of assist the pathologist to focus more on taking the judgment and spending time on where it matters. The routine task gets taken care of, as well as it learns over time. So who is the teacher over here? It's the pathologist who's actually teaching the machine, and machine is learning and constantly evolving. And to do that, and it is assisting the pathologist to become more efficient, focusing a lot more, getting more time to to learn new areas, getting into further specialization. So most of the routine work gets taken care of. So if I can give you an example, we just opened our reference lab in Abu Dhabi, and this is the largest lab of the region, which has an existing capacity of more than 30 million tests in a year, which is expandable to 55 million. In this, every step of the way in the lab, there is some role of automation and learning. One can talk for hours on it, but if I keep it at the very, very high level, when the samples come in, there are automated sample sorters which can scan the code, can put it in different trays, sort it out for you. Then it gets into a automated track where the machine knows the vial, it opens the cap on its own, nothing is touched by hand. It knows which machine to go to from the barcode. It does the test. It puts the cap back in for the balance sample. It gets stored in a particular temperature at a push of a button on a screen. If I need to retest anything, it knows which sample to sort of search for, bring it back into the machine to test. So all of that can happen from a screen and pressing a few buttons. Going forward, of course, there are other specialized area of the lab, like anatomical pathology or histopathology, which is where your tumors. We do a biopsy to understand, and pathologists do this life and death decision that whether you have cancerous cell or not. So there is AI that is used. We are in the process of implementing digital pathology, where the conventional way of looking at the slides were under a microscope, a glass slide under a microscope. With digital pathology, the slides are scanned, and instead of poring over a microscope, pathologists can see over a high resolution large monitor a whole slide image. And not only that, there are machine learning algorithm which does annotation for you. So it's actually assists the doctors and guides his eyes in a way to say that where is morphological disorder in the whole cell structure, and it assists the pathologist as he or she makes that critical
I
judgment.
feel like that's an important thing to emphasize, and yes, like all of the robotics and automation stuff sounds, like a no-brainer, and also really frees up humans to do more human
Mm-hmm,
work, and,
mm-hmm,
and, and will
mm-hmm,
obviously improve the accuracy of a lot of things too. So that certainly checks out.
mm-hmm,
The point around assisting a clinician, I feel like that we need to
mm-hmm,
lean into
mm-hmm.
that a bit, because
Okay.
in an area like pathology and lab, doing investigations, the
Mm-hmm,
clinician's putting a lot
mm-hmm,
of trust in what the result is coming back. And
mm-hmm, mm-hmm,
if we're in an environment where the results were coming back and it was just kind of this black box that just said, well, this is what the diagnosis is, a clinician
mm-hmm.
might be a little bit like, well, I've got, a lot of clinicians, it's their reputation and their decisions are all based on, there's a lot of trust that's placed in the results that's provided. So, but like you've said, it's kind of in that example, in looking at the digital image of the test, it's drawing the eye, it's assisting the clinician in making a decision as opposed to
Yeah,
making a
it is
decision
not
for them.
make as of now. I mean, I don't think it's making the decision. It's helping the pathologist. It's not replacing the pathologist. It's assisting the pathologist to make quicker, faster decisions. And it's a constantly, so finally pathologist takes the final call. The final judgment call is still taken by the doctor who has decades of experience. And the machine also learns from each of those decision making. It's constantly learning. So the pathologist still remain as the teacher, and the machine is still the student over there.
Yeah. I'd love to hear from you, just as you've seen, this industry evolve when it comes to AI and innovations, where you see some of the challenges or the risks of AI adoption in lab medicine, and how we implement these tools more effectively.
Mhm, mhm. See, any new thing will is an unknown, and any unknowns typically, as human nature, we get a little nervous with whatever is not known. So that is a fundamental human nature. So, and the pace at which so-called industrial revolution 5.0 is happening, sometimes it's difficult to keep pace at that, and it's right to worry. So I'll tell you what my belief is, that most of the healthcare industry that was developed, the regulations, the systems, the boundaries, the goalposts, the checks and balances, most of it were developed in an analog world, keeping in mind that it is a tumor board which is only has doctors in it, infectious control board which only has human on the other side. So humans made the system for humans on the other side, and it's evolving. So slowly, as AI and machine learning and automation is coming in, and probably in healthcare, pathology has been slightly ahead of the many other parts of healthcare, because we were always about, I always used to joke that we are that part of healthcare where we put a number and put a sign against it, right? So we were always about putting a specific number.
Yeah.
That's what pathology is always about. So yes, so our systems and all also need to evolve. People talk about AI bias. Yes, that's a very very valid thing, but there is also human bias. So our systems today have the checks and balance in place to monitor human bias. That's why you have boards, right? That's why you have clinical boards, so that it's never one person's decision. So as we are evolving in AI, yes, AI can have AI bias as well, but we'll have systems developed so that it is, again, like not one doctor taking the final call in those most critical areas. It is not one machine taking the call. So there is always that checks and balance which brings in, and we are evolving as we speak towards that era. But it's hugely exciting, because what it can do, because as much as you can think about, there is a limit. When you are doing pathology, a large part of it is to check how you are doing today, right? How your biomarkers are today. With the kind of bioinformatics that is coming in, with the amount of data computing powers and analysis that's coming in, it's much easier today to look at your clinical history, look at your behavior, look at your lifestyle, and start doing predictions. It's still early days, but the real power of AI will not only be to tell you how you're doing today. I can do a test and tell you whether you have sugar or not, right? So that can be done even without AI. But with AI and with bunch of other data points, it can probably give you a score that how you are going to be tomorrow. Those, that's the world of genetics and personalized medicine and everything else that happens. So which is slowly about predicting a little bit, or giving some glimpse of what can the future be.
Yeah. I really like that. How you've drawn the inference of the analog guardrails for the analog world, and if we're bringing into the new world the artificial intelligence side, then the frameworks, the regulation needs to come along with it, and I can see how we can build a effective system around that. So I really like that approach. You mentioned the personalized medicine, and I can only imagine, given that diagnostics plays a huge role in helping patients know more about their own individual health situation, that personalized medicine is front and center of your mind at the moment.
Yeah, so personalized medicine is quite the talk point globally in most healthcare needs, one may say. And yes, diagnostics and genetics play a very critical role, critical component of the personalized medicine. At the very fundamental level, it makes the distinction that what is right for you is not necessarily right for me, or necessarily perfect for me, right? So personalized medicine, or diagnostics, the field that we are evolving is pharmacogenomics. And you can hear from the name pharmacogenomics, there is a pharma component. It can sort of guide the physicians and the patients that what medicine is more suitable for you and what medicine may not work, right? Like if you are hypertension, and that's very, very normal, that not the same medicine doesn't work with two person who has hypertension or high pressure, because the genetic makeup of people are different. So depending on your germline mutation, depending on your lifestyle, and further gene expression or somatic mutations, as you call them, you are a different human being genetically than me. So what works for you doesn't work for me. So doctors know what medicines to prescribe a lot better. It can even tell you your susceptibility to long range diseases. It can tell you how susceptible. It's not a firm predictor, of course. Pharmacogenomics or personalized medicine is not playing God, but clearly it can tell you what the propensity of you to say have Alzheimer's 30 years hence. Doesn't mean that you will have it or not have it, but if you know that you have a propensity, then you sort of impact your lifestyle in a way that your mental capability never sort of rest. You constantly keep yourself busy, your brain busy, so that way you can delay dementia, you can delay Alzheimer's.
No, it's a really fascinating area, and one that, as you say, has got a lot of attention in terms of personalized medicine, and then leading into the genomic side that you touched on. Do you see that genomic insights or genomic testing will play a role in routine lab workflows? Because I think about day-to-day interactions on a clinician side. One of the biggest challenges I personally think in genomics is just the awareness or the literacy of an awareness that these tools exist and what you then do with that information. So, and in a routine lab, everyone knows what to do with routine labs, or at least on the clinician side. I'd love to get your thoughts on that.
Yeah, so yes, today if you see the world of lab medicine, and if you purely talk about the volume play, so to say, in today's world, of course, a large part of the test and all today is obviously non-genetic, which is with your other body fluids. But genetics is the fastest growing, and with few of the things that is evolving, and there were some challenges of it becoming mass streams. I am of a fundamental opinion that genetics will only play a lot more involved role. It's very important even today, but and it's no longer a fringe. Maybe 10 years, 15 years back, it was just a fringe section. It's no longer. It's becoming much more closer to mainstream. And when some of the challenges that we face today gets sorted out, a simple one, just to say, is a large part of genetics is data computation. Right? So when you do a whole genome sequencing, it is about millions and millions of data points that get sequenced, right? So that you have the next generation sequencing platform, which say our genetic center, which we opened last year, has. It does a huge amount of sequencing. What we have seen in the last few years, because of better computing, because of cheaper computing, let's put both ways, both better computing, faster computing, and cheaper computing, it's only a question of time when this overall cost of doing genetic test hopefully will come down, and that will make it a lot more accessible and affordable for larger part of the population. More awareness will grow, because and again, very much like AI, will genetics come and replace blood work? No, it will not replace blood work, but obviously it will be a better sort of pivot as we move healthcare from what I call currently sick care, or taking care of people who have already fallen sick, to real healthcare, which is preventive care. So it's about taking care of you when you don't have a need to go to a doctor, and their genetics or genomics is a far better predictor of future than the current. So while the blood work is a very good, very robust, very well scientifically proven predictor of your current, there is no beating genomics about predictor of the future. And when you get into preventive care, you need to target people who are today healthy, who wants to remain healthy for a long time.
Yeah. No, look, it's interesting that you bring up the very valid point that one of the limiters, I guess, is computing power and the sheer power that's required to do some of the genomic testing. And we know, as we've seen in other parts of innovation, that there's there's those real restrictions, but that also has I guess an environmental impact too, and sustainability is pretty mission critical for a lot of organizations. And I guess I'm no lab technician, but if I think about, the ins and outs of doing a lab in those kind of steps you talk about, there's bits and pieces, there's physical things, it's tangible. And so no doubt, trying to do things in an efficient and innovative way, but at the same time balancing those sustainability requirements too. Walk me through your thinking there on how a lab can continue to be efficient and at scale, but also be sustainable.
Great. So yeah, Pete, that's a interesting and a very important point leading on to sustainability. We are very proud to be part of the organization Pure Health, which has taken a commitment for net zero emission by 2040, 10 years ahead of the country. So we are, as Pure Lab, we are aligned to that vision. And a few of the areas that we are currently looking at, when we select platforms, of course, we look at the clinical capability, we look at commercial efficiency, but we also look at power emissions. We look at emissions of every platform from the vendor. So that also we keep as a checkpoint to ensure how do we, and we have specific targets. So we have my scorecard has a specific percentage emission reduction year on year. And every year the target is only higher and higher as we move towards our net zero goal by 2040. We are also a network lab. As I said, we have close to 150 labs. So samples move from smaller lab to reference labs. So we have sort of replaced all our, to start with, the IC fleet into a hybrid fleet. And once all of UAE, Abu Dhabi and Dubai has much better, probably once we have even better charging infrastructure, we may even think about moving from hybrid to a full electric or whatever. So that's one direction. Of course, then there are AI optimized lab operation that we have, which also reduces emission to a large extent. Less human interventions, faster processing. When you do faster processing, you automatically reduce emission, right? So when you run your machines for longer, your emission becomes higher. And then there are obvious ones in the admin department of paperless offices and AI-powered smart report, which doesn't need you to sort of take a print of your report. All our labs have lab information system. It gets integrated to the hospitals. So hospital doctors don't necessarily have to take a print on a paper to see the report. He or she sees it on the computer. So it's a mix of many things that one is doing towards reducing emissions.
Yeah, there's some big impact things in there, but obviously those 1%ers make a difference, and obviously could be some real inspiration to labs and healthcare providers generally, and think about how we can all play a part. Lastly, to kind of round out the conversation, Arindam, I think you've given us a pretty clear vision, or at least I'm getting glimpses into your vision for the future, or the direction that things are going. But I'd love for you to kind of put a cap on it, and kind of in the next 5-10 years, how you see, I guess, the future of diagnostics evolving and your vision there.
Thank you, Pete. I can only guess. I wish I knew everything that lab medicine will have. I'm no expert over here. At best,
10 years feels pretty long these days, though. Looking at the rate of innovation,
yes,
10 years is a long time. We've got to say 1-2 years now.
Next year, some innovations will come in which you and I have no clue about today.
Yeah.
Let me confess that. So let me confess that. So we really don't know what will come in. But I can only crystal gaze with a limited knowledge that I have. So yeah, we have spoken about AI automation. So I won't repeat that. We spoke about genomics. I won't repeat that. Those are definitely trends which are here to stay. Not repeating those, but definitely those are here. Other things that I feel will happen is with better technology, the point of care testing is evolving. So, so again, labs will not disappear, but the big box lab that we have, where huge machines on a floor, yes, they will be there. There will be those reference labs, which will still do very high-end tests. Next generation sequencing will still happen in huge NGS platforms. Those will happen. But at the same time, need for lots and lots of the small labs over time, over the years, will be lessened. because the machines will become smaller and smaller, and it can be taken to your bedside, whether you are at home or whether you're in a clinic. And while even today and even 5 years back or 7 years back, POCTs were there, point of care testing, but it's developing in a very, very fast manner. And COVID taught us as well some of the point of care testing tools of COVID. Some best known companies of the world did it, were as good, if not better, than large machines. So that's the future. So lab will go to people's home. Lab will go rather than samples coming to lab. So there'll be both. I can see both parallel happening, and they are not counter to each other. Specialized test more and more will come to centralized reference labs. So there'll be a huge amount of consolidation where there will be large reference lab where high-end test will get consolidated. And at the same time, there's a reverse flow where some of the routine test will go to the bedside in point of care. So that's one trend that is definitely going to be. And with that, with AI, with genomics, I'm a firm believer that a lot more focus will be on preventive diagnostics, much more than what it is today. A lot more focus will be on prevention versus cure after. Because currently, if you look at the overall healthcare system, it's almost built to treat patients. So you are a patient and then your journey starts. So I think overall healthcare and pathology and lab medicine will move with it, if not faster than that, will move more towards prevention, where a larger proportion of our target set will be, people like you who look in pink of health.
Yeah. Now, look, I'm glad you brought up the point of care testing and also the preventative side, because if I draw parallels to industries of software, for example, where more and more software became directly available to end users, and there was a much more focus on user, like improving the user interface and making them easier to use and more attractive to use. I as you mentioned, that we saw through COVID, the first generation of the tests that we did compared to near the end, they got better and better and got easier to use. And you see many other versions for those that are interested in longevity and wellness and everything, wanting to do preventative tests. They're getting easier and easier to use, tying in with apps, all those things. So I'm super interested in seeing how that point of care testing does, and I feel like that plays a role in improving accessibility and also improving scalability too. So I'm super glad you brought that up. So look, I think we've covered a lot of ground, Arindam. I really appreciate you making the time for this conversation. Looking forward to seeing some continued innovations from PureLab in the coming months and years. Thank you so much.
Thank you, Pete. It was wonderful talking to you, and thank you for having me here.
Amazing. And thank you at home for tuning in to Healthcare Matters. Make sure you subscribe to the show on Apple Podcasts, Spotify, or YouTube so you can catch all the future episodes. This one was powered by Medlab Middle East in partnership with PureLab. My name is Peter Birch. I'll see you next time.